hopefully I've cleared this thing out for y'all, and we've got a new setup here. So our new series, you can actually see it a little bit clearer than my drawing here, is it's going to go from 1 to infinity, and it's going to go from 1 to infinity of 1 over 3 to the n plus 2. So this doesn't look like a p-series. I have a number raised to the nth power, so that should hopefully make us think of something a little bit different, and maybe in the same vein as the last one. The one we can maybe compare this to is going to be from 1 to infinity of 1 over 3 to the n, which you may not immediately recognize as geometric, but it is in fact geometric because I can take that nth power and take it to the outside like this. Because 1 to the nth power is always going to be 1, and 3 to the nth power is going to be 3 to the n. So you can see that these two things are the same. So in fact, this series right here is a geometric series. And that same series, right, this one right here that I have kind of boxed in this light green color, is always going to be bigger than the original series, since its denominator is in fact smaller, just like the last problem. And so that means since this is a geometric series whose common ratio is a third, which is less than, whose absolute value is in fact less than 1, we now know that this geometric series converges, so therefore this series right here converges. Okay, so just like the problem before, we have another series that is bigger that converges, and since it is bigger and converges, we know the smaller series also converges. Alright, so now on to our third example of the direct comparison test. If you didn't see it before, here it is down here, number 3. It's the summation from 1 to infinity of 2 to the negative n factorial, which already looks pretty disgusting. So let's kind of rewrite that in a slightly less disgusting way. This will be 1 over, since that negative exponent can make us take this to the denominator, 1 over 2 raised to the n factorial. So still pretty disgusting. It's not often you have an n factorial in an exponent, but I kind of want to remind you that that is also the same as saying 1 over 2 all raised to the n factorial. And I think maybe this will help you kind of see where we need to go with this particular comparison. And now we've got something raised to the n factorial. It's a small number in here, so maybe this kind of makes me think of the summation from 1 to infinity of 1 over 2 raised to the n, which is a geometric series of r of 1/2, which again is less than 1, which means it converges. And you can see if I'm going to the nth power down here for this geometric series, the other one has an n factorial. As my n's go up, the exponent in the original series, this one right here that I've boxed, is going to be much larger. And if the exponent is going to be much larger and the thing inside of it is less than 1, then that number is going to be smaller than the one inside this thing that's just raised to the nth power, which means that my series that I've kind of chosen, this geometric series, is always going to be bigger than 1/2 to the n factorial. And since this thing, this geometric series over here, does in fact converge, then I know that this series right here also converges. Not converges. Converges. There we go. Okay, Last one to look at for the direct comparison test. You can see over here it is the summation from 1 to infinity of 1 over 2 plus root n. And this one's actually going to work a little bit different than the others, because you may, after you've seen the other three that we've worked, kind of think that we're looking for this p-series or geometric, and the first one that you might think of is 1 over root n, because that looks very similar to what's in here. And so far we've been choosing ones that are very, very similar to what is actually inside the series we're trying to determine its convergence or divergence. But if we compare it to 1 over root n, which this is a p-series, okay, this is in fact a p-series with a p of 1/2, because that is n to the 1/2 power right there. Okay, this is the sum from 1 to infinity of 1 over n to the 1/2. We would say that that means that this one right here diverges. And so that may make you think immediately we now know that this one we're trying to compare to over here, this one right here that I've kind of circled in orange, is going to also diverge. But there's one problem. And the problem is that this function here, this 1 over root n, is going to have a smaller denominator than the one I've circled and the one we're trying to compare to. And that means that it is larger, right? It is larger than this function, this current series, excuse me. And if we are larger than that other series, then, and it diverges, well, that doesn't tell us any information. That means that this thing sums up to infinity right here. This thing goes all the way up to infinity, keeps getting larger and larger and larger. And since that one goes to infinity and it's bigger, we can't necessarily tell any information about the previous series. So we really cannot choose 1 over root n as our choice. We're going to have to choose something different. Okay, so we've realized that we cannot choose 1 over root n. We have to come up with some other choice. And we need something that we know about that is either bigger than this and converges, or is going to be smaller than this and diverges. Remember, those are our two options. We either need something bigger that converges, or smaller that diverges. Okay, and if you think about this for a while, you might come up with a good candidate. And a lot of this, y'all, is just going to be practicing. This is why you're going to have to do the problems that I'm going to give you. The more practice you get, the more likely you're going to be able to actually figure this out on your own when it gets to be a test time. Okay, so this isn't going to be something that's just going to magically come to you one day in the midst of you sitting at home. You're just going to have the epiphany moment without having actually worked some problems. So the one that you might come to is 1 over n. And I don't know if y'all remember in class we talked about how 1 over n is called the harmonic series. And it is also has a p of 1, which means that it diverges. And the nice thing about this is that I know that n is, as my as this thing goes out to infinity over here, okay, n is going to be bigger than 2 plus a square root of n. The square root of n is going to kind of keep that thing a little bit smaller. So since this n down here is going to be larger, right, this denominator is going to be larger on this one, that means we're going to end up with a smaller fraction. So now, since we have a smaller fraction, that means we know that the sum from 1 to infinity, 1 over n, as things get large, is going to be a lot smaller than 1 to infinity of 1 over 2 plus root n, which is great for us because we know 1 over n diverges. So if we know that this thing kind of goes off to infinity, right, then, or diverges, then we know that this one up here that is larger than it will also have to diverge. Okay? Alright, great job. So I hope you kind of got a good idea of the direct comparison test. And the next one we're going to go to in our next little mini lesson is going to be on the limit comparison test.